Since we're going to be doing free body diagrams quite a bit over the next couple of weeks, it's useful to have a method for identifying forces. And what I've done here is pull together several of the figures in your book that discuss that. Up in the top left corner, there's a list of some of the forces that we'll encounter with the notations that we will use to identify them. And then there is a method, a process for identifying the forces acting on whatever object of interest is under study, and then there's an example detailing the application of this methodology to identifying forces on a bungee jumper. So I'll go back and forth between the tactics box and this figure right here. So the figure is one of a bungee jumper who's attached the bungee cord to her feet, and she's made the jump and she's approaching the end of her jump. As discussed up here, we draw a surface separating the object of interest, the bungee jumper, from her environment. And so any contact force is going to touch or breach this surface. And so if we look down here, the bungee cord breaches this surface, and so it qualifies as a contact force of some kind. In this case, it would be the force of tension in the bungee cord, acting actually like a low K spring. Now, again, remember there's, broadly speaking, two kinds of forces: contact forces, tension being an example of that, and then non-contact, or what your book calls long-range forces. And in this case, there is a long-range force acting. It's gravity. That would not breach the surface since it's a non-contact force. And so this is a pretty simple situation. If one ignores air drag, there's really only two forces acting on this bungee jumper: the tension, the contact force, and then the force of the earth pulling the bungee jumper down, which is the force of gravity.